What's up, you friggin' geniuses? So in this video, I'm going to teach you how to determine the number of solutions, consistency, and dependency of a system of equations, okay? So as you can see, I made a handy-dandy table right here that's going to help us out. We're basically going to use it for the first example, and then I'm going to take some pieces away for the next two examples, okay? Now, there's basically three different scenarios you might run into with these types of problems. So I'm going to do one example of each one, starting with this one right here. So this one says, determine the number of solutions if it's consistent or inconsistent and dependent or independent. And then this is the system that we're given, right? Y is equal to 3x minus 1 and y is equal to 3x minus 6. Okay, so this table down here that I made basically are just steps. Okay, so this is step number 1, figuring out what your slopes are. Step number 2 is your intercepts, figuring out the intercepts. Step number 3 is the line type. Number of solutions is 4. Consistency is 5, and dependency is 6. Okay, so first of all, let's figure out the slopes. So we want to figure out if the slopes on these two equations are the same or if they're different. Okay, now the way we're going to do that is using the slope-intercept formula, which is this bad boy right here. Y is equal to mx plus b, okay? Now, if you remember, this m right here is your slope, and the number at the end, the b, is your intercept, right? Your y-intercept, okay? So if we want to figure out what the slopes are, let's compare the slopes. So on this first equation, the slope is 3, right? Positive 3. And on the second equation, it is also positive 3, okay? So since we have the same slopes here, that means we're going to either go down this row right here, or we're going to go down this row right here. Okay, so since we figured out the slopes, right, has the same slope, now let's go to step number 2, figuring out the intercepts. Okay, so are the intercepts the same or different? Well, again, the intercepts are these numbers at the very end, right? So this one is -1 and this one is -6. So these are obviously different intercepts, right? So it looks like we're going to go down this middle row right here, okay? So next thing we have to figure out is the line type. So if we were to graph these two equations, would they be coincident, parallel, or intersecting? Well, since I told you we're just following this row, you could figure out that they're going to be parallel, right? But let's say you didn't have this handy-dandy table. Let's say on a test. How could you figure out that they're parallel? Well, if you wanted to, you could draw yourself a quick little graph. Okay, here are my axes, right? This is my x-axis, this is my y-axis, and then I could do a really rough sketch of these. Okay, so if I'm going to graph this first one, I have an intercept at -1, right? So let's plot a point at -1-ish. And then here we have an intercept at -6. So let's plot a point there, -6-ish. Okay, and as you can see, they have the same slope, right? Positive 3. So I know it's going to be kind of a steep slope like that. Okay, so that's, we'll say, good enough. And this one should have the exact same slope, right? Because they have the same slope up here. Okay, so as you can see, they have the exact same slope, but different intercepts, right? So that makes them parallel lines, okay? So again, if you have the same slopes, but different intercepts, you should have parallel lines, okay? Now, why do we want to figure out the line type? Well, that helps us figure out what the number of solutions is, which is the first part of our question, right? Determine the number of solutions. Now, if you're trying to figure out the number of solutions, that's really just talking about touch, okay? It just wants to know how many times do both of your lines touch. Well, since these are parallel lines, that means they're never going to touch each other, right? We can extend them in this direction forever and in this direction forever, and still they will never touch, right? So that's why they have 0, right? 0 solutions, because they have 0 points in common. Okay, so the number of solutions right here is 0. 0 solutions, okay? Now let's go to number 5 here, the consistency. All right, so if we want to figure out if this system right here is consistent or inconsistent, that just has to do with how many solutions it has, okay? So if it has one solution or more, then it is consistent. But if it has 0 solutions, then it is inconsistent. Okay, so that's why this system right here is inconsistent. Okay, and the last thing we have to figure out is the dependency. Okay, so is this system dependent or independent? Well, a quick way you can kind of figure that out is just by looking at the little graph that you made. Okay, so if you have clearly two different lines here, then your system is independent. Okay, because these lines are independent of each other. Okay, that's why we have independent right there. So right here, we could just write it one more time. So this system is independent. Boom, right there. Okay, so this system has zero solutions, it's inconsistent and independent, right? So hopefully that wasn't too bad. Let's do another example. Okay, here is our second example. So this one says determine the number of solutions if it's consistent or inconsistent and if it's dependent or independent. Okay, and here is our system. Y is equal to negative 2x minus 3 and x plus 5y is equal to 5. Okay, so as you can see, I took away some of the juicy tidbits from the table, but I kept in just the steps. Okay, so we can practice with just the steps in case that's all you're allowed to use. Right, so the first step, again, is just figuring out your slopes. Okay, so how do we do that? Well, again, we're going to use this formula right here. Y is equal to mx plus b. Okay, so let's make sure both of our equations are in this form. So as you can see, the first equation is already in slope-intercept form, but the second one isn't, right? So we need to change it to slope-intercept form. And in order to do that, we basically just have to solve for y right here. We just have to isolate y by itself, right? Because that's how it is over here. The y is just by itself. Okay, so the first thing I'm going to do here is get rid of the x. So I'm going to subtract x. And what you do to one side, you do to the other, right? So then these x's cancel out, and we're left with positive 5y is equal to 5 minus x, right? Or I can flip that and write it as negative x plus 5, right? Negative x plus 5. Okay, and now in order to solve for y, I need to get rid of the 5, so I'm going to divide by 5. And what you do to one side, you do to the other, right? So we have to divide everything on this side by 5 also. Okay, so then these 5's cancel out, so we're just left with y is equal to negative x divided by 5. You can also write this as negative 1x divided by 5, right? And negative 1 divided by 5, that's just negative 1/5, right? So negative 1/5, and then we have the x at the end right there. And then here, 5 divided by 5 is equal to 1, okay? So here is our second equation in slope-intercept form. Y is equal to negative 1/5 x plus 1, okay? So again, what we want to do here is compare the slopes. So here, the slope is negative 1/5, right? And then in our first equation, the slope is negative 2. So as you can see, we clearly have two different slopes, right? So here we have different slopes, okay? Now let's go to the second step, the intercepts. Well, when you have different slopes, the intercepts actually don't matter. So step number 2, right here, we can actually just skip it, okay? So again, you can only skip it if you have different slopes, okay? So now let's go to step number 3, the line type. So again, the 3 different types are parallel, like in the first problem, intersecting, or coincident. Well, again, in order to figure that out, you could make yourself a little graph and just do a rough little sketch of these, okay? Now, if I wanted to graph my first equation right here, my y-intercept is at negative 3, right? So we'll just say about there is good for negative 3. And the slope is negative 2. So that's negative 2 over 1, kind of a steepish slope. So we'll just say something like that is good, okay? Now, if we want to graph this second one, the y-intercept is at positive 1. So plot a point right there, positive 1. And the slope is negative 1/5. So that's a fairly shallow slope, right? That's not very steep at all. So maybe something like that-ish, right? Close enough. Now, are these lines, are they parallel, intersecting, or coincident? Well, whenever you have two lines that have different slopes, they are always intersecting, okay? And you can see that they intersect at a single point right here, right? So our line type right here is intersecting. Good. Okay, now let's go to number 4. So what are the number of solutions that we have for this graph right here, for this system? Well, again, this is the touch one, right? So at how many points are your two lines touching? Well, here it's just 1 point, right? This is the only point where the two lines touch. So it has one solution. And I'll just abbreviate solution, okay? Now let's figure out the consistency and dependency. Okay, so again, if you have one solution or more, then your system is consistent, okay? So as we just figured out, we have one solution, right? And you can even tell by looking at the graph. So since we have one solution or more, that means this system is consistent. Okay, and then lastly, the dependency just has to do with your lines, okay? So do you see two completely different lines here? Yes, you do, right? So that means they are independent of one another, okay? Independent. Okay, so we've covered parallel, we just did intersecting. You could probably guess what the next one is. Okay, here's the last one. So this one says determine the number of solutions, the consistency, and the dependency, right? And this is the system we're given. 3x minus 2y is equal to 4, and y is equal to 3/2 x minus 2. Okay, so again, first step is just figuring out the slopes. Are they the same slope or are they different, okay? So again, we're gonna do that by putting both of these equations into slope-intercept form. So as you can see, this first equation is already, the second equation is already in slope-intercept form, right? So we just have to change this first one. So let's do that right here. 3x minus 2y is equal to 4. Okay, so let's solve for y right here. So first thing I'm going to do is get rid of this 3x by subtracting 3x, and what you do to one side, you do to the other, right? So then these 3x's cancel out, and we're left with negative 2y is equal to 4 minus 3x, or again, I can reverse those as negative 3x plus 4, okay? So then in order to solve for y right here, I need to get rid of this negative 2. So we're going to divide by negative 2. And what you do to one side, you do to the other, right? So then these negative 2's cancel out, and we're just left with y is equal to, here, negative 3 divided by negative 2, that's equal to positive 3/2, right? And then we have the x right there. And then positive 4 divided by negative 2 is equal to negative 2, right? So then here we have, rewrite it right here, y is equal to 3/2 x minus 2, right? So we converted this first equation to that one right there, okay? So again, first step is figuring out the slopes, right? So do these two equations, right, this one and this one, do they have the same slope? Well, as you can see, they do, right? They both have 3/2 as their slope, okay? So they have the same slope, right? Now let's figure out the intercepts. Do they have the same intercept or different intercepts? Well, as you can see, they have the same intercepts, right? Negative 2 and negative 2. So these are also the same, okay? So as you can probably imagine, since these two equations are the exact same, when we graph them, it would be the exact same line, right? So if we're trying to figure out what the line type is, then it would be coincident, right? So coincident lines are when you have the exact same line, okay? And we can, again, make a quick little sketch of that just to help us with the next problem. So if we wanted to graph this, we'll say the y-intercept is at negative 2, so that's about negative 2. And then the slope is positive 3/2, which is kind of like that. All right, good enough. Okay, so if I wanted to graph this equation right here, y is equal to 3/2 x minus 2, that's what it would look like. Okay, and if I wanted to graph this one, 3x minus 2y is equal to 4, well, again, we changed it to this one, right? Which just happened to be the exact same as this one right there. So if we graphed it, it would just lie exactly on top of it. Wow, that's pretty good. I'm really proud of myself for that. Wow, it's pretty straight. Okay, So you can see one line literally lies on top of the other, okay? So for the fourth step, the number of solutions, how many solutions do we have? So the three choices again were infinite, 1, or 0. Well, in this case, we would have an infinite amount of solutions, right? Because if you remember, this is the touching one, right? So at what points do both of your lines touch? Well, they're both touching right there, right there, right there, right there, right there, right? Along the entire line, they are always touching because one is literally just on top of the other. They are the exact same line, okay? So that's why they have an infinite amount of solutions, right? Now, if we're trying to figure out the consistency, remember, if it has one solution or more, then it's considered consistent, okay? So since we have an infinite amount, which is obviously more than one, this is consistent. Boom, okay? And then lastly, the dependency. Remember I told you if you have two different lines, they are independent of one another, okay? But when you have two lines that are the exact same, then they are dependent on each other. Okay, so coincident lines are always dependent. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below. Also, there's a couple playlists attached that I think you'll find helpful, so definitely check those out, and I'll see you there.